Now, one thing that we've talked about in mathematics that I want to re-emphasize here is something called the rule of 4. 4 is about 4 main ways that people have of thinking about mathematics. It's about 25 years old. It's probably as important an idea as, I don't know, it's at least as important an idea as intermediate value theorem. I was going to say the fundamental theorem of calculus, but it's a really important concept to have in your back pocket. And the 4 ways that we identify to think about problems are symbolic. So we've seen this notation, which is pronounced in choose K. But there's a definition that also would go in this verbal slot, and this is the number of K element subsets of an N element set. And we saw already that there's a formula for this. Before I do that, let's talk about a numerical information that we could put on this. So using the definition that this is the number of K element subsets of an 8 element set, what is 4 choose 0? How many 0 element subsets does a 4 element set have? 1, the empty set. There's one subset that doesn't have any elements always. What about 4 choose 1? Yeah, there's 4 elements. Pick one. If you're trying to pick 4, this is not numerical, so it probably shouldn't go here, but if you want, what is 4 choose 6? 0. You can't pick 6 elements from a 4 element set. What is 4 choose 3? 2 ways you can pick a 3 element set. You can say I'm going to pick 3 elements, or you can say I'm going to pick the element that I'm not picking. 4 choose 5 is also easy. So we're going to leave visual for a moment. Often visual becomes harder, right? How would you do a visual representation of this idea? It's harder. You go from calculus, where visual is the easiest way to represent something, where you can graph it, to something like this, where you have to think about it. Yes? And technically these should be, I don't know how tall 2 is, but I know that 3. And then what's 4 choose 4? There's one way. Well, now the question is, what's the height of 2? Well, we have a formula, which is kind of cheating. I could have made you brute force it. But 4 choose 2 is 4 factorial over 2 factorial times 4 minus 2 factorial, which is 4 factorial over 2 factorial times 2 factorial. 4 times 3 times 2 times 1 over 2 times 2. Cancel. And I get 4 times 3 over 2, which is 6. It would be better to make a better diagram of this, but I think we did okay for improvising. Now this conceptually is a mess because this is not numerical and this is not visual. So apologies about that, but I think y'all get the idea, right? Now what I'm going to ask you to do is to take of these ideas and see, can we take numerical things that we've seen and translate them into symbolic things? Well, now what we're going to do is we want to look at the problems we've seen that involve numbers and see, can we translate them into symbolic problems?